Simple graph. What is simple graph? A graph having no parallel edges, no self loop, is called simple graph. Okay, graph having no parallel edges, no self loop is simple graph. Now this graph, check this graph. Suppose this is the graph G having vertices V1, V2, V3, V4, V5. So you have 5 vertices, E1, E2, E3, E4, E5, E6, E7, 7 edges. Okay, this graph G is not simple graph because this graph has self loop E3 and E5, E6, these are parallel edges. So E5, E6, these are parallel edges. We have self loop E3. So this graph is not simple graph. Okay. Now if we delete this edge E3, suppose deleting this edge E3 and any one of these two edges E5, E6, suppose we delete this edge E6. Now this graph. Okay. This is the graph having no parallel edge, no self loop. So this is simple graph. This graph is simple graph, but the previous graph was not simple graph. Okay, so simple graph means a graph having no parallel edge, no self loop is called simple graph. Okay. Degree of a vertex in a graph. Degree of vertex in one graph. This is undirected graph having. So suppose this is the graph G. We have this graph V1, V2, V3, V4, V5, 5 vertices and 8 edges. Okay, containing self loop E3, E5, E6. These are parallel edges. Now, what is degree of a vertex? Suppose V1. Suppose this is the vertex V1. Now this vertex V1 adjacent to two edges E1 and E2. So this vertex V1 adjacent to two edges E1 and E2. Now what is degree of V1? Degree of this vertex V1 is the number of edges adjacent to this vertex. Sorry, incident to this vertex. Sorry, incident to this vertex V1. So V1 incident to two edges E1 and E2. V1 incident to two edges E1 and E2. And degree of this vertex V1 is number of edges incident to V1. So it is 2. Okay, degree of this vertex V1 is 2. Now, degree of this vertex V5. Degree of this vertex V5, number of edges incident to V5, 1, 2, 3. 3 edges. Okay. Now, V2, degree of this vertex V2. Degree of this vertex V2, number of edges incident to this vertex V2, 1, 2, and for self loop, for calculating degree of vertex, for self loop we count twice. Okay, so for self loop take 2, 1, 1. So 1 plus 1 plus 2, it is 4. So for self loop we count twice for self loop. Okay. So for finding degree of his vertex, degree on vertex, for self loop we count twice. So degree of this vertex V2 is 1 plus 1 plus 2. So for self loop we count twice. So degree of this vertex V4 is 2. Degree of this vertex V3, 1, 2, 3, 4. So degree of V3 is 4. Degree of this vertex V3 is 1, 2, 3, 4. Degree of this vertex V3 is 4. Now degree of this vertex V4, 1, 2, 3. Degree of vertex V4 is 3. So V1 degree 2, V2 degree 4, V3 1, 2, 3, 4, V4 1, 2, 3, and V5 3. Okay. Now what is handshaking theorem? Handshaking theorem. Handshaking theorem, for any graph, sum of degrees of all the vertices of the graph is 2 into number of edges. Okay, so sum of degrees of all vertices equals to 2 into number of edges. Okay, so sum of degrees of all the vertices of a graph is 2 into number of edges. Now for this graph, see, for this graph, number of edges is suppose number of edges equals to, we have 1, 2, 3, 4, 5, 6, 7, 8. 8 edges. We have 8 edges. Now, degree of vertex V1 is degree of vertex V1 2, degree of vertex V2 4, degree of vertex V3 4, V4 3, and V5 3. So, calculate sum of degrees of all the vertices of this graph. I equals to 1 to 5, 5 vertices. Degree of vertices of D is Vi, sum of degrees of all the vertices of this graph. D is Vi, that is degree of V1 plus degree of V2 plus dot dot up to degree of V5. Sum of degrees of all the vertices of this graph. Degree of V1 it is 2, V2 degree of V2 is 4, V3 4, V4 3, V5 3. So this is 6, 10, 16. Okay, sum of degrees of all the vertices of this graph is 16, that is 2 into number of edges. Number of edges is 8, that is 2 into number of edges. 2 into number of edges. Okay, so what is handshaking theorem? Sum of degrees of all the vertices of a graph is 2 into number of edges. So first calculate degree of each vertex, then calculate sum of degrees of all the vertices of the graph. Summation I equals to 1 to n, d is Vi. You will get 2 into number of edges. Okay, so the formula is summation I equals to 1 to n, d is Vi. Sum of degrees of all the vertices graph is 2 into number of edges. This is handshaking theorem. Okay. Now, what is regular graph? In regular graph, every vertex has the same degree. Okay, in irregular graph, every vertex has the same degree. Suppose this is one graph V1, V2, V3, V4, and it is simple graph. So it is simple. A simple graph is regular. A simple graph is regular if every vertex has same degree. Okay, a simple graph is regular if every vertex has same degree. So this is one simple graph, no parallels, no self group, so it is simple graph. Okay, now degree of vertex V1, it is 2. Two edges are adjacent to this vertex V1, so degree of this vertex V1 2, degree of vertex V2 also 2, d is V2 2, degree of this vertex V3 also 2, degree of this vertex V4 2. So each and every vertex has the same degree. So this is regular graph. So a simple graph is regular if every vertex has the same degree. Okay, so this is one example of regular graph. Simple graph, it is no parallels, no self group, so it is simple graph. Now each and every vertex has the same regular graph. Regular graph. See, this is one regular graph. No parallels, no self group. This graph has no parallels, no self group. It is simple graph. Now degree of this vertex, is 3. Degree of this vertex 1 to 3. Degree of this vertex 1 to 3. Degree of this vertex 1 to 3. Degree of this vertex 3. Degree of this vertex 3. So all the vertices have same degree. Also, no, this graph has no parallels, no self group. So it is regular. Okay. So regular graph is first. It is simple graph. All the vertices have same degree. Okay.